Hello everyone. Today we've got a IGCSE Further Pure Maths past paper question from January 2012, paper 1, question 1. And the question here relates to these two lines. It's 4 marks. And we just have to show that these two lines on the graph are perpendicular. So how will we go about that? Well, this is quite a straightforward question. So I want to take this opportunity to sort of create something that's useful to you in the long run. So we're going to try and first, even though our first instinct in an exam would be to try and find the gradients of these, I'm going to try and do it for the general case so we can come up with an interesting formula. So say we have these equations of a line, and they're in the form ax plus by is equal to c. What do we do here? Well, to find the gradient, we want to isolate it so that we have it in y is equal to mx plus k form. Usually it's mx plus c, but I'm using k to make sure we don't get mixed up. And so to get here, you'd want to first divide both sides of the equation by b, so that a over bx is equal to, a over bx plus y is equal to c over b, or y is equal to minus a over bx plus c over b. So if you want to make a note of that and put it in whatever electronic flashcards or study notes or whatever that you use, that's actually going to be quite a useful thing for you to sort of memorize as a mental shortcut, where this is the gradient and this is the y-intercept. Anyway, that's sort of unrelated to the, well, it is related to the problem at hand, but it doesn't directly attack the problem at hand. So let's deal with it, okay? So the formula we just sort of synthesized and made up. It applies to equations like this in the general case, but to illustrate how it works, I'm going to walk through step by step the actual solving of these equations down to a y equals mx plus c form. So say you have 6x plus 4y is equal to minus 15, and we'll call this line L1. You divide both sides of the equation by 4, so you get an isolated y term. 6 divided by 4 is 3 over 2. And then minus 15 divided by 4 just becomes the fraction minus 15 over 4. And then we move the x term to the other side of the equation by subtracting it from both sides of the equation. So if we minus 3 over 2x, then the equation becomes y is equal to minus 3 over 2x minus 15 over 4. And this is useful to us because the gradient here of this equation in the form y is mx plus c is minus 3 over 2. Now, to have used the formula directly would require us to have the memorized knowledge that the gradient m is equal to minus a over b, where a is the coefficient of x, 6, and b is the coefficient of y, 4. And that would have also led us to the correct answer, minus 3 over 2. So that's what I mean by a shortcut that I have made up for you. So we now know that the gradient of line 1, which we'll call m1, is equal to minus 3 over 4. Minus 3 over 2. So now let's give this same treatment to the other equation in question, as we are given that 10x minus 15y is equal to 9, the first thing you'll want to do is to isolate the y term. So since this is a negative number, one thing you can do, rather than just dividing by negative 15, is to add the y term to both sides so that you have a positive y on one side. This really is down to personal preference because either method is valid if you're trying to just answer the question, but to me it looks much nicer on the eyes and in the brain to do that. So it sounds silly, but it's just what I prefer doing, so we're going to do that. So if you add 15y to both sides, 10x is equal to 9 plus 15y. And we can also move this 9 to the other side. As you can see, we're kind of doing the process in reverse to the other way we did it with the other equation. We move 9 back to this side by subtracting it from both sides, because you want to get rid of the 9 term on here. So 10x minus 9 is 15y, or rather 15y is 10x minus 9. So how do we get from here to the gradient? Well, this equation is not in the form y is equal to mx plus c yet. And what would we do to get rid of the 15 that's conjoined to the y? Well, we divide both sides of the equation by 15. So dividing 15y by 15 is just y. Dividing 10x by 15, you get this fraction that cancels out to 2 over 3x, and minus 9 divided by 15. You also get another fraction that cancels out to 3 over 5. So you have your equation, y is positive 2 over 3x minus 3 over 5. And you can tell from this equation of the line that the gradient is 2 over 3. So this is line 2, and we know that the gradient of line 2, which we'll call m2, is equal to 2 over 3. And again, if you were using the formula that I showed you how I made up at the start of this video, it would be the m is equal to minus a over b term, where a is the coefficient of x, meaning this number here multiplied by x, 10, divided by the coefficient of y, this number, minus 15, which would bring us to minus 2 over minus 3, which is just positive 2 over 3. And it's the same result. So our first gradient of the line is minus 3 over 2, and our second gradient of the line is 2 over 3. So how do we get from that information to an actual proof that the lines are perpendicular? Well, think of it this way. If you have a straight line that goes up 3 spaces for every 10 spaces across, how would you make a line that's perpendicular to that? Well, firstly, either you would need a line that goes left 3 spaces for every 10 spaces up, or it goes right 3 spaces for every 10 spaces down. And either way, this is just one line. We're looking for just one gradient of this line. So say we have an arbitrary line that's like, it goes up a spaces, a units for every b units right, and you want a perpendicular line that instead goes left a spaces for every b spaces up. If this makes sense to you, if you would like a more detailed reason why we can claim that this A is equal to the A over here and this B is equal to the B over here, I would advise you to look at the angles of the lines we're making, because this is a right angle and this is a right angle. So if this were theta, then this would be 90 minus theta, and this would be also theta by the sum of the angles in a triangle adding to 180 degrees. So they're a similar triangle, and they have sort of the same ratio of the sides. So anyway, for two lines to be perpendicular, if one line's gradient is A over B, then the other line's gradient needs to be, well, if we look at this delta y, our delta y is plus b, and our delta x is minus a because we're going leftwards here. Our gradient, or our delta y over delta x, is minus b over a. So if one line is a over b, the other line has to be minus b over a. Or in other words, the gradient of a perpendicular line is the negative reciprocal of the gradient of the first line, which basically means that mb is equal to minus 1 over ma, negative reciprocal, or, to the most useful aspect in proving this, ma multiplied by mb is equal to minus 1. So we're going to use this property of perpendicular lines' gradients to prove that the two lines in the question are perpendicular. So MAMB must be minus 1, so let's try it. Since the first gradient multiplied by the second gradient, which is equal to minus 3 over 2 times 2 over 3, and the 3's here cancel out and the 2's here cancel out, is equal to minus 1. Therefore, the two lines are perpendicular. And that is how you would do this question. My upload schedule, it's a bit of news for the people who are following me already, but if you aren't following me already, please subscribe. My upload schedule is going to be, I will try to guarantee a video every Sunday, and it may be a further pure past paper, or it may be what I like to call a creative or an interesting video, like the one I did for board students leaving year 11. If I can't think of a creative video to give to you, then the week will be 3 past paper questions on Sunday, Tuesday, and Thursday, all uploaded at 6 p.m. Hong Kong time, which is 10 a.m. Universal Coordinated Time, UTC. And for instance, that would probably be about 3 p.m. in India and Bangladesh, or 4 p.m., 5 p.m. in Myanmar, and 10 or 11 a.m. in the UK. And Tuesday and Thursday will be a further pure past paper question, and Sunday will either be that or a sort of creative and interesting video about something in maths or physics that I've seen and want to share with you guys. So anyway, thanks for watching. Please like and subscribe.